Dear students, in this lecture we will study the hydrolysis of weak acid and strong acid and a weak base. For this, if suppose we have HCl is a strong acid and suppose weak base, that is NH4OH is weak base. By the combination of this, okay, you remove the H2O, you will obtain the NH4Cl. Okay, this is a salt obtained from the weak base and the strong acid. Therefore, that salt is called as salt of weak base and strong acid, or salt of strong acid and weak base. Okay, in this lecture we will study the hydrolysis of NH4Cl. Okay, when NH4Cl is added water, it gives the NH4 plus and the Cl minus. Okay, in this case we will, as previously discussed, we will use that H plus ion, that is the acid. Okay, that is acid is obtained from that base. Okay, after losing OH minus ions, you obtain NH4 plus. Therefore, it is a weak base. Remember that NH4OH is a weak base. It gives a strong acid. That relation we have known, that weak base gives after losing OH minus ions, it gives the plus species is a strong acid. Therefore, those quantity, okay, among these two, that is a weak. Okay, this is obtained from the strong acid. Okay, therefore that is a conjugate base is the weak conjugate. This is a weak conjugate base. Okay, therefore that weak conjugate is not, you can breaks the H2. Therefore we will use the strong acid which can break H2O. Okay, now we will take the NH4 plus, that is the strong acid, that is conjugate acid of the NH4OH. Therefore, NH4 plus, add the water, the NH4OH by breaking, you will obtain NH4OH and our H plus ions. Okay, that is use the extra H plus ion, that is when you add this salt in water, it will be the acidic in nature. Its pH will be less than the 7. Okay, now by applying law of equilibrium, we can find out the constant, hydrolysis constant, that is denoted by the KH. Therefore, KH is equal to the left hand side concentration NH4OH H plus ions upon the NH4 plus, that is the KH. Okay, therefore NH4OH that is the strong acid you will obtain from the weak base, that is the NH4OH. Okay, therefore we will use the NH4OH and dissociate. Okay, that is a weak base, therefore it can dissociate like that, NH4 plus, and it gives the OH minus. Okay, by applying law of equilibrium, the degree of ionization, that is for the base it is denoted by the Kb, for the acid it is denoted by the Kb. K. Therefore, Kb is equal to the concentration of these dissociated ions upon the non-dissociated bit. Concentration of right hand side upon the concentration of left hand side. Therefore, NH4 plus is concentration OH minus upon the concentration of NH4OH. Okay. Then we know that the ionic product of water denoted by Kw. Kw is equal to H plus ions and OH minus. Okay, 3 we have found the KH, and we have found the NH4OH, and we have found the Kw. Okay, therefore by dividing Kw by Kb, okay, as like we used in the salt of weak acid and the strong base. Okay, the Kw upon Kb. Kw, that is the value of Kw is the Kh plus ions and the OH minus ions is equal to H plus ions and the OH minus ions upon Kb is equal to NH4 plus and the OH minus. NH4 plus and the OH minus upon NH4OH. That upon will be multiplied to NH4 plus and the OH minus. Multiplied to the, that is NH4 OH. Okay, this the common term will be cancelled and OH minus cancel. Therefore, NH4OH H plus upon NH4 plus. Okay, therefore, Kw upon Kb is nothing but we found that KH. Okay, NH4OH H plus and NH4 plus. Therefore, Kw upon Kb is nothing but the KH. Okay, that relation we have found. That is the ionic product upon ionization constant of base is equal to nothing but the KH. Okay. Then degree of hydrolysis. Okay, NH4 plus is hydrolysis the water gives the NH4OH and H plus ions. Okay, that is the degree hydrolysis takes place. Okay, we are interested in to find out the degree of hydrolysis. Degree of hydrolysis means the number of ions of the salt, number of ions hydrolyzed of the salt upon total number of salt taken. Okay, that is denoted by the H. The initial concentration of NH4 plus is the C. Then it's a 0 at the start. Initial concentration of this dissociation will be 0 at the time, very 0 time at the start. Okay, at the equilibrium, you found that. Okay, we have known that H is equal to number of salt hydrolyzed. Okay, number of this NH4, it could dissociate number of NH4OH and NH4 plus, that is the number of salt, and total number of salt taken. Total number of salt, that is the initial, therefore H upon number of salt hydrolyzed upon total number of salt is the C. Therefore, number of salt hydrolyzed, okay, that number of salt hydrolyzed means that this quantity will be is equal to C into H. C into H. Therefore, this will be at the equilibrium CH and CH. Therefore, it is converted into CH. Therefore, initial concentration will be, you have to remove the CH, then initial concentration will be removed. CC is the constant, C minus 1 upon H is your initial concentration. Okay. Therefore, by applying, okay, that is relation is Kw upon Kb is equal to KH we have found. Okay, that by applying law of equilibrium, we can find out the KH. Okay, already we find out the KH. Okay, concentration of this upon this. Okay, concentration of the reactant into first reactant CH, other reactant H plus is the CH upon concentration of NH4 plus. That concentration C 1 minus H. Okay, the H quantity, okay, hydrolysis is takes place very less amount, that is equal to negligible hydrolysis is there, negligible water breaking takes place. Therefore, H is equal to, we have taken the 0. Therefore, 1 minus 0 is equal to 1. Therefore, CH into CH upon C, and C 1 CC is cancelled. Therefore, C H square upon, that is CH square, that is KH is equal to CH square. Therefore, H square is equal to KH upon C. Okay, therefore KH is equal to, we know that KH is equal to KW upon KP. By putting the values, H square is equal to KW upon KB into 1 upon C. Therefore, by taking the square root of this, H is equal to square root KW upon KB into 1 upon C. That is the relation we obtain. Second relation, H is equal to KW upon KB into 1 upon C. That is the second relation we have obtained. Okay, now we will find out what will be the pH when the salt added in the water. Okay, therefore we know that the concentration of H plus ions is equal to CH in this case. Okay, it directly gives the, okay, that is NH4 plus H2O gives the NH4OH plus H plus. Okay, it directly gives the concentration of, that is H plus is the CH. Okay, therefore concentration of H plus ions, okay, is equal to CH. Okay, therefore minus log H plus ions is nothing but the pH. Okay, therefore we have to convert H plus ions into minus log. Okay, before that we have to put the H value. H value we have known that H is equal to C into H is equal to Kw upon Kb into 1 upon C. Okay, then C will move to the in square, that will C square Kw upon Kb into C. 1 Cc is the cancel, therefore C Kw upon Kb. Okay, now we will take the minus log of both sides. Okay, minus log H plus ions is equal to minus log, okay, for this bracket term will be Kw into C Kb raised to 1/2. Okay, that can be changed. Okay, minus log pH means the pH is equal to that 1/2 will be outside the bracket if log is there, minus log Kw minus log C, then minus log 1 upon Kb. Therefore 1/2 minus log Kw minus log C, that is Kw will be revert like that, plus log Kb. Therefore 1/2 minus log Kw minus log C minus and minus log Kb. Okay, we have to interested in the minus log Kb. 1/2 log minus log Kw is the pKw, that minus log as it is. Okay, we will take the next to is minus log C. Okay, 1/2 more, that is minus log C, and in this case minus log Kb means the pKb. Okay, therefore 1/2 pKw minus 1/2 pKb minus 1/2 log C. Okay, that is 1/2 is multiplied to the all the terms. pKw we know that pKw is the value is the 14, the 1/2 14 is the 7 minus 1/2 pKb and minus 1/2 log okay, that's log pKb have log C. Therefore the minus quantity means 7 minus this quantity, therefore the pH value is less than the 7 for the weak base, salt of weak base and the strong acid. Okay, in this lecture we have studied the different relations of the salt of weak base and the strong acid. Thank you very much.